This is Shannon, an open source autonomous AI pen tester that performs code analysis and executes live exploits using browser automation to find all kinds of security vulnerabilities, from server-side request forgery to cross-site scripting to SQL injection and much, much more, giving you a detailed, comprehensive security report with 0 false positives. But with the announcement of Claude Code Security and also the fact that Shannon is built on the Claude SDK, meaning you can't use your subscription, is there any point in learning a tool that might not be around for that long? Hit subscribe and let's get into it. In one of my previous jobs, we'd pay thousands of dollars to external pen testers before a major release, only to find out there were bugs we needed to fix, and then we'd get it tested again, costing us lots of time and of course money. But this is exactly what Shannon exists to fix. You can run Shannon as many times as you want. You can even put it in a CI/CD pipeline and run it automatically, and because it's open source, it's completely free. Well, there is a paid version, which we'll talk about later. But as someone who's not a security expert, I'd rather run my project through Shannon than boot up Kali Linux. In fact, let's see Shannon in action. So Shannon is built using the Anthropic Agent SDK, so you're going to need a Claude API key for it to work. Unfortunately, the subscription won't work either. But I've got it installed on a VPS using a non-root user, and I'm going to run it against the OWASP Juice Shop, which is an app designed to have loads of vulnerabilities for testing reasons. Now, I've already cloned the Shannon repo, which you'll need if you want to run it. And for this to work, you'll have to have your repository you want to test inside the Shannon repos directory. So I've got Juice Shop inside here, and with the Juice Shop project running, I'm going to run this command, which will connect to the app running locally for browser testing and connect to the repo inside the repos directory to scan through the code. Now, if this is the first time you're running Shannon, because it uses Docker Compose, it will first have to pull a bunch of images from Docker Hub. But because I've already gone through that process, it just jumps straight to here. We get a link to the Temporal workflow, and we can view it using the web UI, which looks like this, showing all the steps that need to take place. Or we could run this command to view the logs in real time, which I sometimes prefer since the web UI doesn't always show the most information. But wait, what's Temporal? I thought we were talking about Shannon. Well, Shannon pen tests can take 1 or many hours depending on the size of the project, and Temporal ensures durable execution no matter the scenario. So if your computer crashes midway through a pen test, or you run out of Claude credits and need to top up, you don't lose any progress. Temporal remembers exactly where you left off and restarts Shannon from that checkpoint. Let me know in the comments if you want a dedicated video about Temporal. But it also orchestrates all of Shannon's phases and activities. And even though there are only 5 phases, a lot of things happen inside them. Let me show you. Starting with the pre-flight phase that makes sure API credentials are valid, Docker containers are ready, and the repo actually exists. Then the pre-recon stage, which analyzes the code to understand how the app works. So architecture, mapping entry points, and security patterns. Next is the actual recon stage, which is very different from the pre-recon because here, Playwright is used to navigate through the app. So it will click buttons, fill in forms, and use that to observe network requests, take screenshots, look at cookies, basically map out all the functionality of the app. And then phase 4 does 5 pipelines in parallel. So here we have injection-related vulnerabilities and exports, then cross-site scripting, vulnerabilities and exports, then authentication, server-side request forgery, and finally, we have authorization, so accessing privileged data or other people's information. And all of this happens in parallel on 5 different agents for vulnerability and then another 5 for exploits. And finally, we have phase 5, which compiles everything into a comprehensive pen test report by combining the last 5 checks. Speaking of report, let's see how our pen test is coming along. So after almost 2.5 hours, the full process is complete. And we can see here it started with the pre-flight validation before moving on to the pre-recon and then the recon agent. And then here it runs all the vulnerability checks. So we've got the injection vulnerability agent, cross-site scripting, authorization, SSRF. And you can see for some of these, the green line is not solid. This is because it had to retry because I ran out of Claude credits. So you can see there's a 2 here. And for these ones, there weren't any retry. So it may have been faster than 2.5 hours if it wasn't for these retries, but I don't think it would have been less than 2 hours. Anyway, after it's done the 5 vulnerability checks, it then moves on to do the 5 exploit checks. So we can see SSRF here. We've got the auth exploit, we've got the injection, and so on. And once it's done all of those, we can see the auth exploit takes the longest. It then wraps everything up using the report agent. Now, of course, if we wanted to, we could expand all of this to see more information about each stage, but I'm no expert on Temporal, and I'm sure if we go through their documentation, there'll be a lot more on how to use the platform. But let's now take a look at the final report Shannon has generated. So here in the deliverables directory of our Juice Shop project, we can see the list of all the reports it generated, and it's a lot more than I thought it would do. So let's first take a look at this report, which is the auth analysis. We can see it has a summary at the top, and over here it's noted that there are 11 critical vulnerabilities identified, and we can see what they are. So 0 out of 6 authentication endpoints enforced HTTPS, which makes sense because I was running it locally. And then we also have the proper cache control, which it was missing, and the authentication endpoints didn't have adequate rate limiting. This is really detailed. I mean, if we scroll down, we can see exactly what the problems were, where they were, and the endpoints that caused them. Now, I'm not going to bore you and go through every single report, but let's go through the summary, which is called Comprehensive Security Assessment Reports. And inside here, we have details about the model that was used, the scope of the project. And now if we scroll down, we can see that it found 4 critical auth vulnerabilities that were fully exploited, and it lists them down here. Wow, this is very thorough, but take a look at this. If we scroll down even further, it gives us a summary of the report. So this is the first idle one, and scroll down even more, we can see exactly how an attacker could exploit this. So the exact curl command they could run with the details and the type of information they could extract. And this level of detail exists for every single vulnerability, which goes to show how much detail went into the assessment. Now, if you're interested, I'm going to leave a link to all the reports inside this description. But 2.5 hours is a really long time for Claude Sonnet to scan through a repo. Is there anything Shannon Pro could have done to help? So it doesn't look like Shannon Pro could help with the speed, but it does do some other things, like provide CSVV scoring, which the basic or free version does not contain. It has CI/CD pipeline support, API access, and more importantly, if you're an enterprise user, you get all the things you'd expect, including OWASP compliance reporting, as well as SOC 2 and PCI DSS. So even though 2.5 hours is a really long time, I've done some research and found out the first run of Shannon takes the longest and then subsequent runs are much faster. Now, I know what you're thinking. Almost 2.5 hours running Claude Sonnet 4.6 on a single pen test. How much did that cost in credits? Let's just say a lot. I topped up about $66 and ended up having this much left. So almost $60 in Claude credits was spent running this pen test, which is cheaper than hiring a human tester, but it's still a lot of money. And I would have loved to use my Claude Pro or Max subscription, which would have made the whole thing a lot cheaper, which is hopefully what Claude Code Security will allow you to do when it's properly released, unless the team at Keygraph end up rewriting Shannon in something like the OpenAI Agents SDK or use the Vercel AI SDK, which allows you to use many more models. But overall, if you're a startup and don't want to spend a lot of money on a human pen tester, then Shannon is a good alternative. If you're an indie hacker with even less money, then maybe hold off and just release the product to see if people will actually use it. And while we're on the topic of AI and security, if you want to know how to safely install OpenClaw on a VPS, then check out the next video where I go through step by step exactly how to do that.